Hi, I'm Paul Hopewell. Welcome back to my workshop. In this quick video I'm showing you how I made a cranking handle for my Alba 1A shaper. In my previous video titled Alba 1A Shaper Fix, I showed you how I dealt with a few issues except for one. When I bought my shaper it had an old crank handle, and that was a very loose one and spent more time on the floor than a carpet. The one I've been using doesn't fall off, but it needs a collar allowing it to fully rotate. I intend to make my crank handle using old stuff out of my well-worn bits box. I've got an old 7/8 AF socket and it's a 1/2 inch square drive. It'll fit all the square drives on the shaper. Next is a bit of an old vice handle. It came with one of my budget vices. I think it's made of cast steel. And lastly, a hand wheel with a free moving grip. I don't need the wheel, I just need the bolt-on grip. The thread on this grip is a bit bent, but it'll do the job. The cast steel handle is probably made of rubbish, and I call it monkey metal. It'll probably have all the machining properties of frozen toffee. The problem here is that the socket is chrome vanadium and it's hard material to machine, and I'm going to have to shorten it. To attach the two together I've got a MIG welder, and although it'll weld the socket okay, I'm not too sure about the cast handle. I've got a brazing torch, although it's not acetylene torch, it's a propane torch. Finally I'll put a flat on the end of this old handle and then drill and tap. That should do. One thing I wanted to do before I did too much was to machine the stampings off the side of this socket. After all, I know it was made with an old socket, but I don't want it to keep reminding me every time I use it. I didn't have to machine the end face, it's just habit I suppose. Knowing that this socket is hard stuff, I was going to use a 0.4 rad CNMG insert for less push-off, but I know that the sharper the tip, the more likely it was to chip the insert over the intermittent section. So I chose an insert tool with a 0.8 rad instead. These small hobby lathes are generally designed to use high-speed steel or carbide tip tools. Using insert type tools is for the most part pushing the little machine's limits a little bit too far. To push the tool through the work at the depth of cut that the insert requires to do the job cleanly while transferring the heat into the swarf or chips requires a lot of horsepower. Mind you, the positive rake inserts do work quite well. Okay, I do use various inserts, but often the single belt drive slips or the 1 horsepower motor stalls. The poor finish here is because the insert radius I used is too big for the depth of cut I took. I could have used a carbide tool, but it wanted sharpening and I was being a bit lazy at the time. The insert survived the intermittent onslaught, but because it wasn't cutting efficiently, the heat remained in the part. I'm pretty certain my fingerprints will come back. I took about 6mm, 1/4 inch off the overall length, and because it's quite hard stuff with intermittent tendencies, I used the same 0.8mm rad insert for this second side. If you look carefully, you can see that when the insert started to engage with the material, it required more and more force on the hand wheels to keep it cutting. But I could see that the RPM was dropping as I did so. Plus, the push-off was quite considerable, as you could see it still machining when I wound the tool back out. Yes, there is the possibility that my gib strips require nipping up or locking, and there is some excess overhang on the tool holder. But for the majority of the stuff I do on here, everything's fine. You can also see that I'm now trying to get the heat out of the component and into the swarf chips by the colour of the swarf that's coming off. and for the record, the insert is still in good health. I started by nibbling away at the end face, and I got bored, so I took a little bit off the OD for a few cuts and reverted back to machining the end face because of the intermittent nature of the bore. I can't really remember what RPM I used, but I would think it'd be somewhere around about 800 RPM. And this is where I deburred the outside corner. I can just see thousands of comments flying my way about now asking, why don't you just use a bit of flat bar for this part of the handle and just weld it on? Quick, right? Well, I do have some bar, but I need it for something else. And as I had this lying about forever, and because I'm as tight-fisted as they come, it for me was a good choice. Maybe. Still, nothing ventured. While cutting this old handle, it appears to be cast iron, so there's a turn up for the books. So I've started, so I'll finish. Being cast iron, the only choice I've got is to braze it. That'll be interesting. I first put the cast bit in the vise to support the socket while I braze tacked the two parts together. Then I turned it in the vise to get the braze to run around both parts. The cast part was first heated along most of the shaft and then wire brushed before putting the socket on top. Both parts had quite a bit of flux daubed on them to get the best adhesion and flow. The gas gun, as mentioned before, is a propane torch. It's a Bullfinch 4100. I've used it for bracing small stuff before, and as I also mentioned earlier, it might not quite be up to the job. We'll see. Well, I'm surprised. After getting most of the material up to near temperature, I then concentrated on getting the braze to flow. It did flow, but only in a very small and localised spot. As a result, it took quite a while to get all the way round, but get there it did. It's not pretty, but as I always say, it'll do. And to hide the braze, I used a rattle can spray paint to cover it. I ain't asking my wife to do this. She got more fan mail from painting the shaper than I got for fixing it. I'm not jealous, honest. It's now a matter of drill and tap the handle to get the last bit attached. I buried the tap into the material using the pillar drill, but the chuck was only nipped up so that it would slip as soon as the tap grabbed. Then I could finish the tapping by hand. To be honest, I wasn't sure that brazing would work out and was fully expecting to make another video using my only bit of flat bar. But here we are, it works and it looks okay. And what is more, the thing stays on the machine and it doesn't crash into everything. That's it, job done. Once again, thanks for watching and bye for now.